Children, let us continue the chapter triangle. Now let us continue the exercise based on Pythagoras theorem and its converse. Now you take the fourth question. What is that fourth question? ABC is an isosceles triangle, right angled at C. Prove that AB square is equals to 2AC square. AB square is equals to 2AC square. Now you have the right angle triangle. It is an isosceles triangle and also it is right angled at C. So it is isosceles right angle triangle. Now also it is given that here AC is equals to BC. What is given here? AC is equals to BC. And here you take the solution. In triangle ABC, what is given here? Let us have, as it is isosceles triangle, let us have AC is equals to BC. AC is equals to BC. Consider this is first year. That is given. Given means it is said that it is isosceles right angle triangle, and as it is right angled at C means it is not possible to have the hypotenuse equals to any other side. So here AB is the hypotenuse means AC must be equals to BC. So you take it is given here. Now you apply the Pythagoras theorem to the triangle ACB. So you take angle C is equals to 90 degree. Therefore you write what? According to the Pythagoras theorem, square on the hypotenuse is equals to sum of the square on the other two sides. That is AB square is equals to AC square plus BC square. AB square is equals to AC square plus BC square. What it is? It is Pythagoras theorem. Pythagoras theorem it is. Next you write AB square is equals to, here what you have to prove? We have to prove that AB square is equals to 2AC square. So here you know that as AC is equals to BC, you can take here AC square only. But in the place of BC you write AC. That is BC square means again you can write AC square. That is from first it is. That is from first. Now that is, you know, AB square is equals to AC square plus AC square becomes 2AC square. AB square is equals to 2AC square. 2AC square you got here. As it is an isosceles triangle, you can get AB square is equals to 2AC square. That completes the proof of the fourth question. Now let us come to the fifth question. ABC is an isosceles triangle with AC is equals to BC here, with AC is equals to BC. Now what I have to prove here? It is given that AB square is equals to 2AC square. Prove that ABC is a right angle triangle. Now you take the solution here. Here it is said ABC is an isosceles triangle with AC is equals to BC. So you take the given here. So what is given here? In triangle ABC, AC is equals to BC, and also AB square is equals to 2AC square. You take it is first here and it is given. The reason is here given. Next you take what is given here. If AB square is equals to 2AC square, that is given. Now you write AB square is equals to AC square means you write, you split it AC square plus AC square. 2AC square means AC square plus AC square. So it is AB square is equals to you write one AC square, one AC square only, and the other AC square you write BC square here. So what you got here? Here from first you got, it is, how you got it? From first you got that as AC is equals to BC, in the place of AC square you write BC square. Then here you know that square on one side is equals to the sum of the squares on the other two sides, means the angle opposite to the first side AB must be right angle. So which is the angle opposite to AB here? That is angle C. Therefore you can write angle C is equals to 90 degree. Angle C is equals to 90 degree. Reason here, that is converse of Pythagoras theorem. Converse of Pythagoras theorem. Here it is not given that it is a right angle triangle. We have to prove that it is a right angle triangle, and here it is given AC is equals to BC, and also given that AB square is equals to 2AC square, and you got that here AB square is equals to AC square plus BC square, that is square on the hypotenuse, means square on one side here. AB square is equals to sum of the square on the other two sides. So this angle opposite to the first side AB is 90 degree. Take the sixth question. ABC is an equilateral triangle of side 2A. Find each of its altitude. Here it is given that ABC is an equilateral triangle with measurement 2A. We have to find the measurement of each altitude of the triangle ABC. Now you take the solution here. What is given here? In triangle ABC, what is given? AB is equals to BC is equals to CA, all are equals to 2A here. All are equals to 2A. Now here, to find the measurement of the altitude, here we have to use the Pythagoras theorem. Before that, here we have known that AD, let us have AD, BE and CF are altitudes. Altitudes means, you know, here AD perpendicular to BC and BE perpendicular to AC and CF perpendicular to AB here. So here let us have next. Here as AD is perpendicular to BC, you know that AD must bisect BC and BD must be equals to DC. If you want, you can prove that. So you take in triangle, right angle triangle it is. Here in triangle ADB and triangle ADC are right angle triangle. So you take in right angle triangle ADB and right angle triangle ADC. You know that angle ADB and angle ADC are right angles, and according to the RHS congruence rule, you can prove this, that two right angle triangles are congruent if hypotenuse and a side of one triangle is equals to the hypotenuse and a corresponding side of the other, then these two triangles are congruent. So you take here AB is equals to AC and also AD is equals to AD. Here AB is equals to AC, given it is. AB is equals to AC, given, and AD is equals to AD, common side it is. Common side. Therefore you can write that both the triangles are congruent. Triangle ADB is congruent to triangle ADC according to RHS congruence rule. Therefore you can say BD is equals to DC. BD is equals to DC. BD is equals to DC means they must be half of BC here. D becomes the midpoint and BD is half of. So you take BD is equals to DC. What is the reason you are going to give? CPCT. Therefore here BD is equals to DC. Both of them are equals to what? Half BC. Here D becomes the midpoint. and half of BC means that here BD is equals to DC is equals to half into 2A it is. So you will get A it is. Half into 2A means A. PD you got 2A. Now you apply the Pythagoras theorem to the triangle ADC. So in the right angle triangle ADC, you know that which is the hypotenuse here. AB is the hypotenuse. So you write in right angle triangle ADB, right, AB square. Here AB the hypotenuse means you take AD square plus AD square plus BD square is equals to AB square. Here AB is the hypotenuse. So you have taken AB square is equals to AD square plus BD square, or AD square plus BD square is equals to AB square. Now AD square you write here. BD means that that is A square. AB is 2A whole square. So AD square plus A square is equals to 4A square it is. 2A the whole square means 4A square. Then AD square is equals to, it becomes 4A square minus A square. By transferring A square to the RHS part, you got AD square is equals to 4A square minus A square. So AD square is equals to, it is 3A square. Then AD is equals to root 3A square, that is equals to root 3A. So you got the measurement of one altitude. Similarly, you will get the measurement of the altitude CF and also BE. They are same here. Similarly, you can have that. Similarly, altitude BE is equals to root 3A, and also altitude CF is also is equals to root 3A. So what are the measurement of each altitude here? Therefore, the measurement of each altitude is equals to what? Root 3A. Root 3A. Now you take the 7th question. Prove that sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonal. Here the rhombus is given. You know the property of the rhombus. In rhombus, all the four sides are equal and diagonals are unequal and bisect each other at right angle. They bisect each other at right angle. That is the main property of the rhombus. So you take the solution here. What is given here? ABCD is a rhombus. ABCD is a rhombus. AC, the diagonals AC and BD bisect at O, and you know that ABCD is a rhombus means you can have AB is equals to BC is equals to DC is equals to DA. DC is equals to DA. That in rhombus all the four sides are equal. And also here that diagonals bisect each other at right angle. Diagonals bisect at right angles. Bisect at right angles. Both the diagonal bisects here you take, therefore each other. Diagonal bisect each other at right angles. So you can have here AO is equals to OC is equals to half AC, and also BO is equals to DO is equals to half. BO is equals to DO is equals to half BD you can take here. Therefore, you can take AO is equals to OC is equals to half AC and BO is equals to DO is equals to half BD. Now here there are 4 right angle triangle. Apply the Pythagoras theorem to any one of the triangle. So let us say one triangle. So you take in right angle triangle. In triangle you take in triangle AOB, AOD, whatever it may be, in triangle AOD, angle AOD is equals to 90 degree. That you know, angle AOD is equals to 90 degree. Apply the Pythagoras theorem here. That is, you take AD square is equals to, AD becomes the hypotenuse, AD square is equals to AO square plus BO square. AD square is equals to AO square plus BO square, and that is AD square is equals to, AO means you can take, AO means half AC whole square, BO means half BD whole square. So if you have this is first, so you can write from first, it is from first you can take. Next here it is one more relation that you had. So consider here, this is first, this is second. So you can take this is from second. AB is equals to BC is equals to DC is equals to DA is also needed here. And this one you used here. So you can take here, let us consider this is a second. So here you take from second. You got AD square is equals to half AC the whole square plus half BD the whole square. That is from second. Then that is AD square is equals to, you know that half AC means AC square by 4 it becomes. Plus this is also BD square by 4. BD square by 4. And here that becomes AD square is equals to what? AC square plus BD square by 4. Then it becomes 4AD square is equals to AC square plus BD square. Then here 4AD square you can have, here rhombus is having 4 sides. So in the place of 4AD square you can have the all the sides here. You take here 4AD square means you write AD square plus AD square plus AD square plus AD square, that is equals to AC square plus BD square. So for one AD square you can write one side, that is AB square. Second you write BC square. Next DC square. This is AD only. So you got AB square plus BC square plus DC square plus AD square is equals to what? AC square plus BD square. For this you can give the reason from first, as all the 4 sides of the rhombus are equal. You got the result. What is that result? Sum of the squares of the sides of a rhombus is equal to the sum of the squares of the diagonal. Now you come to the question number 8. What is that question? In the figure, O is a point in the interior of a triangle ABC. OD perpendicular to BC, OE perpendicular to AC, and OF perpendicular to AB. Show that first one, OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equals to AF square plus BD square plus CE square. Second one, AF square plus BD square plus CE square is equals to AE square plus CD square plus BF square. So let us prove first one. You take the solution of first one. To prove first one, what is that first one? That is OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equals to what? AF square plus BD square plus CE square. Now here we have drawn the extra construction is there here, that is AO, BO and OC are joined here. In the figure what is given here? It is given that OD perpendicular to BC, OE perpendicular to AC and OF perpendicular to AB. So what you have done here? AO, BO and CO are joined. Now by joining this AO, BO, CO, you will get 6 right angle triangle, because here all these are perpendicular, means you will get 6 right angle triangle are forming here. So here 6 right angle triangle formed here. Now here see the question here, OA, AF is there. So you take this triangle, and next OB, BD is there. OB, BD means you take this triangle, and OC, C is there. OCC means you take this triangle, and apply the Pythagoras theorem to that triangle here. So you take in triangle OAF, in the right angle triangle OAF, you write here which is the hypotenuse. You know that OA square is equals to OF square plus AF square. Consider this is the first year, that is Pythagoras theorem. Reason you know, that is Pythagoras theorem. Next you take in right angle triangle, which one? BOD you take. In the right angle triangle BOD, again you apply the Pythagoras theorem. It becomes OB is the hypotenuse here, as this is right angle, ODB is right angle, means OB becomes the hypotenuse. You write OB square is equals to OB square is equals to OD square plus BD square it is. So we consider second. The reason is same, Pythagoras theorem. Next in triangle you take OCF, right angle triangle OCF. Here in the right angle triangle OCE, in the right angle triangle OCE, here OCE is the hypotenuse. So you write OC is the hypotenuse here. OC is the hypotenuse because angle OEC is the right angle. So you take OC square is equals to what? OE square plus C square. Consider that is third. So the reason is here same, Pythagoras theorem. Now here what you have to take here, OA square plus OB square plus OC square minus OD square minus OE square minus OF square. So you add first, second, third by first plus second plus third. So what you will get? OA square plus OB square plus OC square is equals to OF square plus AF square plus OD square plus BD square plus OE square plus CE square. Here this is the first, this is the second, this is the third. So you got the sum of the RHS part and also sum of the LHS part. LHS are OA square, OB square, OC square. So you have taken OA square plus OB square plus OC square. RHS are OF square plus AF square, OD square plus BD square, OE square plus C square. Add them. By adding first, second, third, you got this one. Here what you have to see prove here? Here you must transfer OD square, OE square, OF square to LHS. You transfer OD square, first one is here, OD square, OF square, OE square to RHS here. So you transfer OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equals to what is remaining in the RHS. Here OD square, OE square, OF square are transferred to the LHS. What is remaining in the RHS? AF square plus BD square plus C square. So you read what is there? AF square plus BD square plus C square. You got the result here. AF square plus BD square plus C square. In this way you got the proof of the first one. Now let us prove the second one. What is that? What I have to prove here? AF square plus BD square plus C square is equals to AE square plus CD square plus BF square. Here we must apply the Pythagoras theorem to all the 6 right angle triangle. So you take the first one, that is here AO is the hypotenuse of 2 right angle triangle AFO and AUO. So you take that one. In triangle, in right angle triangle AOE, in the right angle triangle AOE, you take here which is the hypotenuse. AO is the hypotenuse. So you take that one. AO square is equals to AE square plus OE square. And in the right angle triangle AOF with the same hypotenuse AOF, again you will have AO square is equals to AF square plus OF square. AF square plus OF square. So consider this is first, this is second here. Then what you will get here? From first and second you will get AE square plus OE square is equals to AF square plus OF square. DOB. Take in triangle, in right angle triangle FOB. Apply the Pythagoras theorem, which is the hypotenuse here. OB is the hypotenuse. You write OB square is equals to FB square or BF square plus OF square. Consider this is the third. And also in triangle DOB or ODB, you write that in triangle which triangle it is? DOB or BOD, you write in triangle BOD or DOB. Apply the Pythagoras theorem here, that is again you will get OB square is equals to OD square plus BD square. This is fourth here. The reason is common reason, that is Pythagoras theorem. Pythagoras theorem. The next you take the next pair here in triangle ODC and triangle OEC. But before that, here you equate from third and fourth. From third and fourth equate. Here as LHS are same, RHS must be equal. So you write From first and second you can write FB square plus OF square is equals to OD square plus BD square. Then take the next pair here. In triangle ODC and in triangle OEC you take. Then you write in triangle ODC and triangle ODC you write the Pythagoras theorem here, that is OC square is equals to, in the right angle triangle ODC, OC square is equals to OD square plus CD square. Again here in the right angle triangle, OEC, you write OC square is equals to OE square plus EC square. So you consider this is fifth, this is sixth, and the reason is here you applied the Pythagoras theorem. So here again you can take from fifth and sixth. From fifth and sixth you take. Again as LHS are same, that is OC square, RHS must be same, equal. So you write OD square is plus CD square is equals to OE square plus EC square. Now here you consider now the relation got from first and second, let us denote this is A, and the relation got from third and fourth, let us denote this is B, and the relation got from fifth and sixth, let us consider that is C here. Now here from A plus B plus C you have here, from A plus B plus C it is, and add LHS of A, B, C taken as LHS and RHS of A, B, C taken as RHS. But here you have to observe, see here AE square plus, in the proof what is there that you have to observe here. What you have to prove here? AF square plus BD square is plus CE square is equals to AE square plus CD square plus BF square. So you take AF square, OF square, and BD square. Here where is BD square? This one. And also next one here CE square. CE square. Here it is CE square. So add LHS, 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 RHS and RHS, RHS. So here first LHS. First LHS is AE square plus OE square. Right? AE square, AE square plus OE square plus second LHS, that is from third and fourth, that is B, FB square plus OF square. FB square plus OF square plus you take OD square plus CD square is equals to RHS of A, AF square plus OF square, AF square plus OF square, and RHS of B, OD square plus BD square, OD square plus BD square, plus RHS of C, OE square plus EC square. Now here you know that OE square and OE square cancels, and also OF square cancels, OD square cancels. So what you will get here, AE square plus BF square plus CD square is equals to AF square plus BD square plus CE square or EC square. CE square. Here you got the result. What is there in the second? What is that? AF square BD square plus, this is, you convert that, interchange LHS and RHS. Here you will get, that is AF square plus BD square plus EC square is equals to AE square plus BF square plus CD square. That is the thing what you have to prove here. See, in the question, AF square plus BD square plus CE square is equals to AE square plus CD square plus BF square. We got the result here. Here we got the same result with the help of the Pythagoras theorem. Now you take the 9th question. A ladder 10 meter long reaches a window 8 meter above the ground. Find the distance of the foot of the ladder from base of the wall. Here let us consider the ladder is PR and PQ is a wall, that is a vertical wall, and RQ is the distance between the foot of the ladder and wall here. So what is the length of the ladder here? That is 10 meter, and it reaches the wall at a height of 8 meter window. Next, what you have to find out? Find the distance of the foot of the ladder from the base of the wall here. Here, apply the Pythagoras theorem that here the wall is always perpendicular to the base. So you take solution here. In right angle triangle PQR, the right angle triangle PQR. So here Q is right angle, means PR becomes the hypotenuse. You write RQ square plus PQ square is equals to PR square. So reason is here, you know, that is a Pythagoras theorem. Pythagoras theorem. Next here, RQ is not given. You write it as it is, RQ square plus PQ is 8 square and PR is 10 square. Then it is RQ square is equals to 10 square minus 8 square. Now here, to get the value of RQ, here 10 square minus 8 square, here you can use the identity a square minus b square is equals to a plus b into a minus b, or otherwise find the value of 10 square, that is 100, minus 8 square is 64. 100 minus 64 becomes 36, root 36 you will get here. So you do anyone here, then you take RQ square is equals to 100 minus 64 it is. Then RQ square is equals to 100 minus 64 is, that is 36. Therefore RQ is equals to, that is root 36. So you got RQ is equals to, what is the square root of 36? That is 6 meter it is. How much it is? 6 meter. Here if you want to use the a square minus b square, it becomes 10 plus 8 into 10 minus 8. 10 plus 8 is 18 into 2 you will get. Again it is 36 you will get if you use the identity a plus b into a minus b. Now here you know the square of 10 and square of 8 easily, means you will get 100 minus 64, that is equals to 36, and RQ is equals to root 36, and RQ is equals to 6 meter. That is the distance of the foot of the ladder from the base. So you take, what is the the distance of the foot of the ladder from base of the wall equals how much here? Wall is 6 meter. Now you take the 10th question. A guy wire attached to a vertical pole of heights 18 meter is 20 meter long and has a stake attached to the other end. How far from the base of the pole should the stake be driven so that the wire will be taut here? Here what is guy wire? It is a tensioned cable designed to add stability to a freestanding structure. Here there is a pole AB which is a vertical pole and its height is 18 meter and the length of the guy wire is 24 meter. And here what you have to find out? The distance from the base of the pole to the stake. Distance of the base of the pole to the stake. So here again you know that pole is perpendicular to the base. So here there is a right angle triangle at B. Now you take the right angle triangle and apply the Pythagoras theorem to find the length of BC here. So you take solution here. What is given here? You know that here AB is given. AB is equals to 18 meter and CA is equals to 24 meter. What you have to find out? BC we have to find out. BC is equals to question mark. And in the right angle triangle ABC, which is the hypotenuse here, as B is a right angle means its opposite side AC is the hypotenuse. And here what you have to find out? You have to find out BC means you write BC square plus AB square is equals to AC square. Then BC square is to be find out, you write it as it is, plus EB. AB is, that is 18 square, AC is 24. Then BC square is equals to, it is 24 square. 24 square minus 18 square it is. 24 square minus 18 square. You know what is the square of 24? 24 square is 576. 18 square is 324. If you know that, you write it directly. Otherwise, you calculate, or it is better to use the identity of A square minus B square. You know that 24 square minus 18 square is equals to 24 plus 18 into 24 minus 18. So 24 plus 18 is, that is 42 into 6 it is. 42 into 6, that becomes 6 2s are 12 and 6 4 2, it becomes 252 you will get. 252. So here it is. If you know the square of 24, you can write it is, that is 576 and 18 square is 324, or otherwise you use this A square minus B square form and write the factors of A square minus B square as A plus B into A minus B. Factors of 24 square minus 18 square is 24 plus 18 into 24 minus 18. That also you can do here. So you write 24 plus 18 into 24 minus 18. Then BC square is equals to, that is 42 into 6. Then BC is equals to, you can write it here, 42 into 6 it is. Then if you factorize it, you know that 6 into 7 into 6 it is again. Then BC is equals to, you know that 6 and 6 are there, means you can write 6 root 7 meter it is. Here it is 6 root 7 meter. So what is the distance between the base of the pole and also stake? Distance between the stake and the base is 6 root 7 meter it is. And here it is known that 6 into 6, that becomes, if there is a doubt here, that is 6 into 6, 6 square it is, 6 square into 7 it is.